A black hole is one of the strangest phenomena in the universe. We often see it in movies as a cosmic monster that devours anything. But what's rarely shown is just how dense it really is. Imagine the entire Earth compressed down to the size of a marble. And if there were a black hole with the same mass as the Sun, its physical size would be so tiny that you could fit 7 of them within an area the size of Bekasi City. That's how insanely dense they are. This extreme density is what creates gravity so powerful that anything getting too close will never escape, no matter how fast it tries to run. Until now, scientists are still asking, what actually happens inside a black hole? To find the answer, we'll try to enter one. So, we're used to learning that gravity is the force of attraction between objects. But Einstein discovered something deeper. Gravity actually bends space and time. Imagine the universe as a stretched-out fabric. Place a rock, like a star, right in the middle, and other objects will just sort of roll toward it. Now, a black hole. Well, it's not just a big rock. It's so heavy that the fabric tears. Anything approaching falls into that tear and, honestly, never returns. But it turns out most black holes are already full. They're not actively devouring objects nearby. Even if the Sun were replaced by a black hole of the same mass, the planets would still orbit normally. We would just, freeze to death because there's no light. Active black holes can be identified by extremely bright light around them. That's the glow caused by matter being forced inward. Let's pick our target, a black hole with mass like the Sun. As we float closer to its edge, we could actually see the back of our own head. Because, light is bent back by extreme gravity. This is why there's a ring of light surrounding it. The nearer we get, the stranger time becomes. To someone watching from afar, our rocket looks like it slows down and freezes, gradually turning red, then disappearing. But for us, time feels normal. Crossing the point of no return, the event horizon, gravity pulls harder on our feet than our head. Our body stretches like spaghetti. We call this spaghettification. But is there a safer way in? If we choose a supermassive black hole, like the one at our galaxy's center, we might actually pass through the edge without being instantly ripped apart. But, the journey is still one way, toward the black hole's center, into darkness that just swallows everything, until the universe looks like a single tiny point, before disappearing forever. There, all matter is compressed into a point of zero volume with unimaginable mass, called a singularity. Almost all black holes spin like a top even close to the speed of light. This rotation creates a region called the ergosphere, where objects are dragged around. With enough energy, escape is possible, but honestly, it's incredibly difficult. Black holes can also collide, merging into something bigger. Our galaxy and the neighboring one are predicted to experience this, though not for billions of years. Where do they come from? The strongest theory suggests that black holes are born from the death of giant stars, supernova explosions of stars at least 20 times the mass of the Sun. But what about supermassive black holes, millions to billions of times larger than the Sun? The universe is too young for them to grow normally. So theories emerged, such as colossal gas clouds collapsing under their own gravity, giant black hole seeds forming after the Big Bang, and collisions of the first stars. The answer remains one of cosmology's greatest mysteries. So, here's the thing. There was a time when we believed black holes would last forever. But, quantum physics actually tells us something different. It predicts that black holes emit what's called Hawking radiation. Over time, they shrink, bit by bit, until, eventually, they just explode. So the problem is, if everything that enters eventually evaporates, where does the information go? This, actually violates the laws of physics. The information paradox remains debated to this day. Can a black hole be destroyed? Well, if you nuke it, it just gets bigger. Crash another black hole into it, still gets bigger. The only theoretical hope? A white hole, which is basically the opposite of a black hole. Instead of pulling matter in, it spews it out. But its existence is unproven. This is the first photograph of a black hole in history, and honestly, it's the result of telescopes working together across the globe. The journey of science is far from over. You know, the discovery of black holes didn't start with telescopes, but with mathematics and curiosity. A scientist predicted their existence from gravitational anomalies. And really, humanity has been searching for proof ever since. Today we know black holes are real. But wow, their mysteries still far outnumber their answers. Black holes are proof that the universe is far stranger than any science fiction we've ever written.